All right, so starting Unit 3, this is Unit 3, Lesson 1, our learning targets. I can interpret graphs by describing what is happening at each section of a graph, and I can analyze situations in sketch graphs to represent a given situation. So each graph has two axes. There's an x-axis, which is horizontal. It runs left and right, and there is a y-axis, which is vertical. Each of these has a label. So in every situation, there's some label for it. It means something. Typically, a lot of times, the x-axis is labeled with time. So it represents time. The y-axis can have a lot of things. So some examples can be speed, distance, distance from a point. Distance traveled, any of those kind of things. So they can represent a lot of things as time passes. Now, x can represent other things too, but most of the time it's time. So look at this graph here. It says you got time, so time is passing. It's a trip to London, and your altitude. So I'm guessing you're in an airplane. As time starts, you start to take off. The airplane gets up to height. It cruises for a while. And then when it gets ready to land, it needs to come down slowly until it lands in London. Okay, so what is the graph showing? It's showing the altitude of a plane over time. So at what point where is a plane, where in the graph is a plane at its highest point? Okay, so where on here, which of these descriptions is it at its highest point? Would be its cruising altitude. So it's at the cruising altitude. Where is the plane going the fastest? There's nothing on here that explains speed. So I have no idea. So we don't know. This graph was not made to tell speed. It was only meant to tell altitude with respect to time. What does the flat portion of the graph represent? So this up here, what does that represent? What's going on right there? Well, it represents a constant altitude. Okay, so when it's flat, the altitude is not changing, but time is. Time keeps going, so it's just staying the same altitude. The next graph. So let's use this next graph. So looking at this guy, we got time, we got total distance. So total distance traveled. So here, distance increases slowly. Then you're waiting for a bus. So notice it's flat. You're not going anywhere. You're not moving at all. And then suddenly, your distance, total distance, increases quickly. And then it kind of slows down a little bit. So what is the graph showing? It's showing the total distance. So the total distance for a person's walk home. Where is the person going the fastest? How do we know? So we want to know when, because remember, speed is how your distance is changing over time. So if distance is increasing quickly and time is not changing fast, then it's going to be going up, 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 up. It's going to be more in this direction. Okay, so time goes fast. Distance going fast, but time's going slow. Whereas here, time going fast and distance going slow. So it almost looks flat. It's a real low slope. But if it's going up quickly, some line like that, that means you're going pretty quick. So where is the steepest? Right here. Okay, while you're taking the bus. Because that is where the line rises the steepest. What does the flat portion of this graph represent? So this flat portion right here, it just means that it's a constant distance. If you have a constant distance from something, that means you're stopped. Whoops, stopping. So it means you've stopped. You stopped moving. Time kept going, but you're not moving, so your distance didn't change. Why does this graph never go down? Well, because the total distance that you traveled, the total distance a person walks, can never decrease. So if I walk 10 feet forward and then walk 10 feet back, my total distance is 20 feet. So even though I came back, my total distance traveled. Now if I had a distance from a point, that's different. This is not distance from a point. This is just total distance traveled. Okay, so flip that guy over. And it says use the graph below to answer the following questions. So look at this graph right here. So temperature compared to time. This is weekend temperatures. So weekend is a Saturday, Sunday kind of thing. What is the graph showing? Well, it's showing temperature over, you say time or the weekend. So over the weekend. Which day is the warmest? Well, if this is a weekend, Saturday always comes before Sunday, so Saturday. Because Saturday had the highest temperature. Which season is shown below? I'm sorry, it was shown here above. So what season is this? Well, it could be summer. It gets hotter in the day, colder at night. The next day wasn't as warm. That sounds like summer. But that also sounds like winter, and it also sounds like fall and spring. So we have no idea. It doesn't give us enough information, so we don't know. That's one of those questions we can't answer, so we don't know. And then the next one here says, which scenario best fits the graph? So we've got speed compared to time. So I'm going to a certain speed. As this goes up, I'm going faster and faster and faster and faster. And then I got a kind of a flat time. Now, does this mean that I stopped? If my speed is flat, that doesn't mean I stopped. That means I'm just not speeding up anymore. So let's say I'm going 1 mile an hour, 2, 3, 5 mile an hour, 10 mile an hour, 20 mile an hour, and then I stay 20 mile an hour. I'm still moving. I'm just not going any faster. So I'm going at a constant speed. And then I go a little bit, and then I speed up a little bit more, and then suddenly my speed drops to nothing. Here I stopped. Okay, so I stop moving, and then I speed up again, constant speed, and then I come to a stop again. So reading through those, I'll give you time to read, or if you want to pause, you can read through them. But yeah, all of these, out of all of these, it's letter C. Okay, so he skates downhill. Why would it be downhill? It's going up. Well, if I'm going downhill, my speed goes up. Maintain my speed for a while, then I pick up a little bit more speed right there before coming to a sudden stop right there. Okay, then he increases the speed again, is constant for a while, and then slows down again. If I'm going uphill, my speed is slowed down. So if I'm skating uphill, I wouldn't start at 0 and then increase my speed. That's not possible. Billy slows as he goes up a hill. He's not slowing down, he's speeding up. So those two are out. It's got to be C. Okay, and then the last guy here, sketch 2 graphs of the Top Thrill dragster at Cedar Point. So I don't know if you guys know the Top Thrill dragster. It's, I don't know how to describe it. You're facing forward, you go really fast up a hill, you turn around, you come back down, and it's like 400 and something feet. It's pretty cool. I've ridden it like 5 times in my life, and it's pretty intense. But we're supposed to make 2 graphs. So one of them we're going to do compared to time. 2 things I could do. I could do speed and I could do altitude. So I'm going to do speed and altitude. Okay, so speed, first off, you're sitting there doing nothing, and then all of a sudden it just accelerates so fast as you're going up towards a hill. So you're speeding up very quickly, and then as you start to enter the hill, you start slowing down. You get to the top of the hill. Actually, I should say you're still going up the hill, up the hill, up the hill, and right about here, your speed is almost nothing because you're on the top of a hill, turning around, you're barely moving, looking down. You start speeding up again. You reach a really good speed, and then you get to the bottom of the hill where they put the brakes on, and it slows you down and takes you back to the beginning. So that would be speed compared to time. Now your altitude compared to time, you're maybe 10 feet off the ground because they can't put you on the ground. So you take off, and for the first few seconds, you're not really that far off the ground. You're flat, and all of a sudden you go up this huge hill. Your altitude goes up, 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 and then you come back down the hill, and you level back off again and go to the starting point. Okay, so there's two different ways. Same roller coaster, but there's two different graphs that can represent the exact same thing. So it's really important what you're talking about. Time versus altitude, time versus speed can look very different.